This is worksheet 8.5 WSP. We're going to be doing the even ones on this video, and you guys are going to be responsible for doing the odd ones. So there's three things that we learned. The first, to pull out the GCF. Actually, two things. No, three, yeah. First is to pull out the GCF, and then the other one's factoring by grouping, and the third thing that we learned was solving equations using the zero product property, which sometimes requires factoring first. But anyways, on number two, the first section of this homework is all about identifying the GCF and writing it on the outside of the parentheses. So what's the GCF between 4d squared and 16? 4. Just 4. There's no d in both of them, so 4 is the greatest common factor. What would be left on the inside? 4 times what gets us 4d squared? D squared, that's right. So d squared, and what else? Plus 4. We are done. Let's move on to number 4. Once again, we are going to pull out the GCF. What is the GCF? Okay, I'm gonna purposely do this the wrong way. You guys said 5AD. And I'm going to go with 5AD, even though that's not the best way to do it. Okay? Because 5AD is not the GCF. It's just a CF. What do I mean by that? It's not the greatest common factor. There's something more that I could have pulled out instead of a 5. Well, 15. But you know what? Let's say you don't see this right at the beginning. So I'm going to continue with this just in case you make a mistake on the quiz. You'll be able to correct yourself later. So if you do pull out a 5AD and then start thinking 5AD times what gets me a 15AD? Well, that would be a 3, right? Yes? Yeah. Okay, and then you have plus, and 5 times 6 is 30. And of course, we also have an AD over here to get that 30a squared d squared. Now, if you have your answer there, and you notice that on the inside of the parentheses, you could still factor more. There's a 3 right here and a 6 right here. So you could actually pull out what? A 3. So let me do this, just so we could see what's going on. The 5AD, there was multiplication up here. I'm going to put multiplication, but I'm going to move it to the left side just to make some space. And then I'm going to pull out the 3 from here. I'm going to pull out the 3's from here. And what would be left right here? In other words, 3 times what would give me the 3? 3 times 1. Okay. So let me put a 1 right here. And then 3 times what will give me a plus 6AD? Plus 2AD. Correct? And now what do we really have? We have the 5AD times 3. So that becomes 15AD. And then the 1 plus 2AD. So that's your final factored form right there. So if we would have just taken a couple of seconds more at the beginning and realized that 5 is not the GCF. Look at 15, look at 30. What's the GCF of those numbers? 15. 15, right? So if right from the beginning I realized that 15 was 15 AD was the GCF, then I could just think, okay, 15 AD times what will give me 15 AD? Well, that would just be 1. And then plus 15 AD times what will give me the 30a squared d squared? That would just be 2 with the AD, right? And there's your final factored form. It's a lot faster than not pulling out the GCF. See, what happens when you don't pull out the GCF, there's still something else that you could pull out, which you have to do, and then multiply that. So either way is correct. It's just, this is a longer path to get to the final answer, 15 AD times 1 plus 2 AD. Could have got that instantly if you would have pulled out a 15 right from the beginning. Let's move on to number 6. So some of us are thinking, yeah, I could pull out a 6, but there's probably more, right? What's a greater value? 12. And not only a 12, but we could also pull out letters. So we are pulling out 12xy. So once we have this set up, then we could think about it and say what would be on the inside. In other words, 12xy times what will get us a 36xy squared? 3. Okay, and we can do a bit at a time. What's 12 times 3? That's how we get the 36, right? And then we go x times what? X times what will give me an x? You don't need to put another x. And then y times what will give me a y squared? Y. So it's really 12xy times 3y, that will give you the 36xy squared. And then how am I going to get from 12 times what to give me a minus 48? 12 times what? Minus 4, correct? And of course, we have an x here, but we need to multiply it by what to get an x squared? An x. And the y, well, if that y is there, it'll be right there. We're good. So that's the factored form for number 6. Now, if you wouldn't have pulled out 12, like if you would have pulled out a 6, you'd still be able to pull something else out. So it's always better to go with the greatest common factor, the 12. Let's move on to number 8. How about here? What's the GCF? 3. And how about a? Now, why is it a? Why is it not a to the third? Because the maximum amount of a's you could pull out from both at the same time is just one a. That's why you're just pulling out one a. Make sense? Now, what about the d's though? What's the maximum amount of d's I could pull out? 2. Because we have d squared right here and d to the third right here. I could pull out a maximum of 2 from both. So you need to put d squared right there. So we have 3ad squared on the outside. And now let's think. 3ad squared on the outside times what will give me a 9a to the third d to the second? Well, 3 times 3 will give me a 9. How about a times what will give me an a to the third? A to the second. Well, let me do that in blue. A to the second. And then d squared times what gives me a d squared? I don't have to multiply it by anything. It's already there. So then I have 3 times what will give me a negative 6? Negative 2. And what about the letters? I have an a. So I'm good. I have a d squared times what will give me a d to the third? Just d. Because d squared times d is d to the third. So that's your final answer. Let me write it nicer. Moving on to number 10. Again, we are pulling out the GCF, but what is the GCF? Is it 2? Is it 4? Is it 8? Definitely 8. And how about letters? P and R. So 8PR is the GCF. And now we need to take some time and think about what's going to be left on the inside. So 8PR times what will give me an 8P squared R squared? A PR right in there. PR. How about for the second term? 8 times what will give us this negative 24? Okay. R to the second. Great. And how about 8PR times what will give us a 16PR? Plus 2. And that's about it. So like let's say you're not sure if you pulled out the GCF. Look at the inside of the parentheses and see if there's anything in common in all three that you could pull out. But as you can see, you can't, so you know you did pull out the 8PR, which is the GCF. And that's it. That's your answer. Let's move on to number 12. And right here, we need to find the GCF. What's the GCF? Is it 9? No. What, 9 times what is 24? It doesn't work, right? It's 3. Okay, so we have the number 3, but what about letters? We have A's in all of them, right? No? What? We have X's. Yeah, so 3X is the GCF. Okay, so what would be left on the inside? 3X times what gets you the first term? 3AX squared. Good. And how about 3X times what gets us an 18B to the X squared? Plus 6. You need that B and an X because X times X is X squared. And the last one, 3 times what is positive 24? 3 times 8, but we still need that C right there, so we're going to say it's an 8C. And we are done with number 12. Number 14, the first one of the even questions that we have to factor by grouping. Now, of course, always try and pull out if something's in common. What do I mean by that? If I had a 2, a 4, a 6, and an 8, you could pull out a 2. And then you could continue factoring by grouping. But right here on number 14, there's nothing in common. There's no A's in all of them. So we are going to go to factoring by grouping. Step one is to make more space between the two groups. So I just rewrote it, and I made space between the first two and the last two. Now after that, I'm going to factor out of the first group. And what's my GCF on the first one?
A.
Just an A. And if I pull out an A, what would be left? 2A. What else? Plus 3. Now how about the second group? I have a 6A plus 9. I could take out a 3, a positive 3 that is, and what would I have left? And that works out great because we have the same exact blue binomial right there. So we're going to take a step back of the whole thing, and I'm going to pull out that 2A plus 3 and put it out here in the front. What would I have left on the inside of the parentheses? The A and the plus 3. And that's it. So of course, let's write this with the correct size parentheses. Number 16. By the way, number 15, you do have to pull out a GCF first. If you want to see that one explained, it's on the other video. Let's move on to 16. Again, always try to pull out the GCF first, but there is no GCF here. There is no multiple of 2 or multiple of 3 in every single term. There is no letter in every single term, so we're going to jump right into factoring by grouping. Let's make space between the first two and the second two. Now after that, you look at your first group, and you decide what your GCF is. That would be a 2 and an x, correct? What would be left on the inside if you pulled out a 2x? 3, just y, okay, and then minus 4. And that's it. Let's look at the second group. What could we pull out of there? A positive 5. What would be left? 3y minus 4 also. And step 3 on factoring by grouping, all you have to do is pull out that common binomial in blue, rewrite that 3y minus 4 out here in the front, of course keep it in parentheses, and what would you have left on the inside of those huge parentheses? There you go. So your final answer is 3y minus 4 times 2x plus 5. Let's move on to number 18. And once again, there are questions like number 17 that you have to first pull out a 2, because all of them are even numbers. You could first pull out a 2 and then continue factoring by grouping on the inside of the parentheses. If you want to see that one explained, watch the other video, the one that's explaining the odd ones. This is the even ones. So on number 18, let's step 1, split them. Step 2, factor out of the first group. What could I pull out of the first group? 3? 3a, there you go. And if you pull out a 3a, what's left? 4a. And then 3 times negative 5 is 15, but we still needed that b, so minus 5b. Now let's look at the other one. And the first thing that comes to my mind is just to pull out a 4, correct? But it'll be better to pull out a negative 4. But I want to pretend that I don't see that right now. I'm going to pull out a 4. And if I do pull out a 4, I will have a negative 4a and a positive 5b. Then I recognize that the binomials are not the same. They're opposite binomials. So instead of pulling out a 4, it would be nice if this negative 4a was a positive 4a and if this positive 5b was a negative 5b. So I'm going to actually factor out another negative 1. So I'm really going to pull out a negative 4 right there. And that would change these signs to be a positive 4a and a minus 5b. So now we really do have the same exact binomial here and the same exact binomial there, because we pulled out a negative 4 instead of a positive 4. And now we could take a step back and factor out that 4a minus 5b, that common binomial, 4a minus 5b, put it in parentheses, and you'll have a 3a left over with the minus 4. And we are done. Let's move on to the back side of this worksheet. Yeah, the answers are not on there. It's more questions. And on this whole backside, numbers 19 through 30, we are solving equations using the zero product property. And the zero product property is cake. Zero product property says that when you have something times something else and it equals 0, you could split them and set them each equal to 0. But we're not doing the odd ones. So let's go to number 20, the even one. So splitting it, I will have 4b equals 0. And then I'll have b plus 4 also equal to 0. And you solve both of them. On the first red equation, you have 4 times b, so you have to get rid of it by dividing by 4. And we should know that 0 divided by 4 is 0. That's one answer. And over here, when you subtract 4, you end up with b equals negative 4. Number 21 is also easy. Why is that? Because it's in 22 is also easy because it's in factored form. All you do is split them and solve. So the first term, a plus 6, you set that equal to 0. And then in the second term, 3a minus 7, you set that equal to 0 and you solve both. This is what we call splitting them. All right? And when we solve it, minus 6, a equals negative 6. That's one answer. And on the other one, I go plus 7. You're going to have 3a equals 7. And the final step would be to get rid of the multiplication of 3 by dividing by 3. And that's your answer. A equals 7 over 3. 24 is also too easy. You split them. And then you solve each of those. So you set them each equal to 0, then you solve. Minus 8, 4y equals negative 8. You're going to divide by 4, and yes, your answer is negative 2. That's one answer. Now for the other, you're going to go plus 4. You're going to end up with 3y equals 4. Final step, to get rid of that 3, you have to divide by 3. So your answer is y also equals 4 over 3. 26. 26 is the very first one that's not ready to split and solve, right? In order for you to split and solve, you have to be able to apply the zero product property. You have to have something times something to give you 0. And right here, you don't have something times something, you have something minus something. So in order to convert this to a multiplication problem, we have to factor. So we're always going to factor first. Well, first you need to make sure that it's set equal to 0, and then you factor, and then you split, and then you solve. So what could we factor out of this polynomial, or on the binomial on the left side? I'm going to cover up the equal 0 for a little bit so we could ignore it. Okay, so what could I factor out of there? 4p. If I pull out a 4p, what's left? 2p minus 1. And now let's remember that this is an equation that said equals 0. So I'm going to bring down that equals 0. Now we truly do have something times something equaling 0. So we're going to split them now. The first something, 4p, that could be equal to 0. And the second something, 2p minus 1, that could also be equal to 0. So we solve both of these. By the way, when we take the quiz tomorrow, when you do this, you have to show your work. You can't just tell me the answers. All right? You have to show your work. If you don't have the correct work, I can't give you the points for it. So you have to show that you factored it, show that you split it, and show that you actually solved each of those equations. So p does equal 0. 0 divided by any number is still 0. And then over here, you go plus 1. You end up with 2p equals 1. Final step would be to divide by 2. So p equals 1/2. So p equals 0 and p equals 1/2 is the answer to 26. Number 28. So this is probably the most entertaining one out of all of them, because you first have to, the whole purpose of the zero product property is if you have something that's equal to 0. And right here, we don't have something equal to 0. Right here, you have 18x squared is equal to 15x. You don't have it equal to 0. Even in semester 1 of algebra, you didn't want x's on both sides of your equal sign. So let's move everything to one side. Let's subtract 15x and subtract 15x. Now we all should know that you can't do x squared take away x. They're different terms, so you're just going to rewrite it. You're going to have 18x squared take away 15x, but we will have equals 0 now, and that's what we wanted. So step 1 here was setting it equal to 0. Step 2 is the factor. Step 3 is to split and solve. So set it equal to 0, factor, split, and solve. So right here, let's factor. What could I factor out of there?
3x.
A 3 and an x, okay. And if I do pull out a 3x from the 18x squared, what do I get? 6 and an x. And how about 3x taken out of the negative 15x? That's a minus 5. Excellent. Reverse distributed property right there. That's good factoring. Now we do have the equals 0. So now we could apply the zero product property because we have the 3x times 6x minus 5 equaling 0. So you could split them. 3x could be 0, and also 6x minus 5 could be 0. And if you solve these two simple equations, you'll have your two answers. So divide by 3, divide by 3. 0 divided by 3 is still 0. Sorry, used the wrong color. And the other one, we're going to add 5, add 5. You're going to end up with 6x equals 5. Final step would be to divide by 6. So your answer on that one is going to be x equals 5 over 6. And it's okay to get fractions. Last one. What do I do first? You tell me. You want to get rid of that minus 26 by doing the opposite, plus 26. What you do to one side, you do to the other side. So since they're not like terms, you can't really add those together, so you're just going to rewrite it. 8x squared plus 26x equals 0. And now we factor. What could I pull out of there? What's the GCF?
2x.
2? Is 2x the greatest?
Yes.
Yeah, it is. It is. 2x is the greatest. Bless you. So what would I have left on the inside?
4x.
Perfect. Equals 0. So now we're going to split them. I want to say, I'm running out of space, I guess, so I'll go up here. I want to say that this 2x right here, 2x could be equal to 0. And I'm also going to say that this 4x plus 13 could be equal to 0. And I want to solve both of them. Right here, you divide by 2, you're still going to get x equals 0. That's one answer. And on the other one, you subtract 13, you're going to end up with 4x equals negative 13. Final step would be to divide by 4, and you end up with your final answer, x equals negative 13 over 4. Disgusting. I'm done, finally. I did the even ones, you guys do the odd ones.